Modern embedded and IoT devices are used in everything from healthcare to smart cities and even improving personal performance in sports. Developers connect these devices to the internet and control them through mobile phones and cloud services, but this often makes the systems less secure. TOZ identity and end-to-end encryption toolkits seamlessly integrate with embedded, mobile, web, and cloud services to ensure data security. This video demonstrates secure role-based access control for device management and application layer end-to-end encryption of data in transit and at rest. So let's go ahead and dive into the demonstration. Here's a Raspberry Pi sensor suitcase prepared to collect data, as well as a wristband Bluetooth monitor. In the upper right-hand corner, you can see it's starting to write data, and it will also display it on the LED screen. The current reading is 76, the heart rate data coming from the Bluetooth wristband. We're also going to collect distance data using the ultrasonic sensors over in the corner, and that data is showing up on the 7-segment display. Here's the data screen itself. In the upper left-hand corner, you can see system status. In the upper right-hand corner, additional status details. In the lower right-hand corner, more data points. And in the lower left-hand corner, information about upgrading the software. Now, here's the device that is reading the data. The other system is writing the data, while this system is attempting to read it. At this point, it does not yet have access to the data, so it cannot decrypt or display it. Here's a close-up of the screens, showing that the data remains unreadable. Now, we'll assume the role of an administrator managing the system. We can see a list of users, both human users and devices. Let's select the identity corresponding to the Raspberry Pi device that is attempting to read the data. From the left-hand column, we see that it is not currently assigned to any groups. We select the heart rate data reader group and add the device to that group. This action performs both role-based access control and a cryptographic key exchange. Now, let's look at the device itself. It should start reading data any moment now, and there we go. In the upper left-hand corner, you can see heart rate data being received and plotted according to the heart rate as measured by the Bluetooth sensor. Now, let's do the same thing for the distance sensor. We add the device to the group that grants access to the distance sensor, and we can now see, in the lower left-hand corner, that the device has begun collecting distance data. There it is, now plotting in real time in the lower left-hand corner. Here's a close-up view of the data reader collecting both heart rate and distance data from our encrypted storage system. This setup uses fine-grained access control with cryptographic key management for multiple sensors and devices. Now, let's revoke access for this device. We remove it from both the heart rate and distance sensor groups, and it immediately loses access to those data streams. Here is a static image confirming that the data is no longer being collected by the reader device. Now, we have one more feature to demonstrate. The board is configured to periodically check for updates, but as you can see in the lower left-hand corner, it currently does not have permission to receive them. To deploy updates to the data collector, we select its identity inside the identity management system and add it to a group called Software Readers, which grants it permission to access, download, and install this update. Now, back at the board, it checks for updates, receives the new firmware, downloads and decrypts it, verifies the signature, and installs the update. Our software development kits provide human identity management for end users on mobile devices and browsers, including secure key storage on their platform of choice. In the cloud, we offer a platform with end-to-end encryption, identity management, and key management, along with secure hardware modules for key storage. For embedded systems, we provide device authentication, access control, data encryption, and enclave-based key storage.